Hello everyone. Today I'm going to explain data go to question 600, non-negative integer without consecutive ones. So this is a classic DigitDB question, and if you're not familiar with the DigitDB yet, don't worry. I'm going to walk you through a whole detail of DigitDB, how you can use it, what is the question that you can use. So let's take a look at this question. So you're given integer n, and then you should return the binary representation count, the number of binary representation that do not contain consecutive one. So what does it mean? So let's look at this example. N equal 5, and the output is also 5. So as n equal 5, from 0 to 5, you can create these binary representation. For 0, obviously it's 0. For 3, it's 1, 1, because the first one represents 1 and the second one represents 2. And 4 is 1, 0, 0. So this one is 2 square 2, so it's 4. And you don't have anything for 2, and then you don't have anything for 0 or 1. So this is 4. So the thing is, you cannot have consecutive ones. So in this example, 3 has two adjacent one. So this is invalid for this um, answer. So you're going to simply count the valid answers from 0 to 5. And in this case, it's a 0, 0, 1, 2, 4, 5. So in total, it's 5. So how you can solve this question? Well, so the easiest way to solve this is a brute force. So you're going to create every single binary representation from 0 to 5, and then check one by one whether it is like it has consecutive ones or not. So what is the time complexity for that? So first, you're going to create this binary representation, go through everything, so which is n. But at the same time, you have to iterate all the numbers as a binary representation. So it takes the time as the length of this binary representation, which is log n, if you think about it. So in total, the time complexity is n log n, which is efficient. It's the same time complexity as sort. It's usually not bad time complexity, but this is a hard question, so we have to make it quicker. So that's where the DigitDB comes in. So DigitDB is often useful when you have to manipulate the number or digit as kind of the string. So let's say, so in this example, we can get this 101 as like a binary representation. But if you write the code, you have to manipulate this number by string, because you have to check one by one. It's no longer 101, it's 101. It's completely different numbers. So even when you solve brute force, you have to check this as a string, not the integer. So that's when DigitDB is really useful. You kind of to convert the number as a string and then think of each digit as like some, I don't know, the factor for creating answer. So let's explain my DigitDB answer right here. So we have several arguments, position and type and prep, and the initial values of those is 0, 1, 0. So first of all, what is position? Position is simply the index, kind of the index of the binary representation. So let's say if the number is 101, the position 0 would be this 1, and the position 1 should be this 0, and the position 2 is going to be this last digit 1. So it's really simple. It's like quite a common like index recursion. happens in an abstract problem or like any other dynamic programming question. It's really common. And then what is tight? This is really important. Like tight is the unique concept in this digit DP. And the thing is, um, so when you have the max this 5, so 5 is n, and obviously you cannot exceed it. You cannot exceed 5. And every binary representation is going to be a 0, 1, 0, 1, like 1 or 0. But how would you know, like when you're at here, when you're at index position 2, position 1, whether you can make it 1 or 0? In this case, no, because if you make this 1, it's going to be more than that. It's going to be 7. So it's more than 5. So you are not allowed to do that. So how would you know, um, like kind of the limitation, the range of the numbers? Can it be 0 only or like 1 or 0? So this is the tight. This is tight. So when it's tight, you can only choose 0. So let's say when you choose 1 first at the first position, and then you come here, it has to be tight because you have to pick up 0, 100%. If you choose 1, that's invalid. So that's what tight represent. And let's say if this is also a good example, if it's 4, 1, 0, when you're at, yeah, so I guess this is actually all the same number. So let's look at the different example. So let's say 7 or 8 actually. So we have 8, and this is as a binary, something like this. So when you pick up 1 at the first position, you cannot choose 1 again. So it has to be tight. So this is the kind of the signal to tell you you have to limit yourself to only pick up 0. So that's really simple. I'm going to explain how we can use this later, but let's understand this as a factor or a signal that you change your logic to make it only 0 or 0 or 1, the range. And the last argument is prev. And the prev is really simple. Prev is actually just an argument for only this question. You don't have to have this prev always in a digit DP. So what this prev does, so because we cannot have two 1 consecutively, so this prev tells you like which number you pick in the last position. And if the prev is 1, obviously you cannot choose 1 again. So you can kind of skip it. So let's go through actual logic. So this DP function is going to start with the base case. So first of all, position is out of range, which means that it is same as the length of self.n. What is this? This is a Python weird syntax, but you can think of this as this binary representation 101. This is basically just the same thing. Yeah, self.n is a binary representation of n. So if it exceeds the index, you are going to return 1. It's just the count of non-consecutive number. What is it? Binary representation that do not have consecutive 1. And you just return 1. And this is just the caching. It can work without this memoization, so let's skip it. So this is the main part. So let's think of this limit. This limit is the significant part of DigitDP. So let's look at this. So first of all, if the tide is equal to 1, which means tide, if the tide is 0, that means it's not tide. So if it's tide, which means that we have to regulate the range of numbers to only 0, you're going to pick up this. I mean, it doesn't have to be zero, sorry. It can be really confusing. So I'll give you another example. All right. So let's imagine this kind of binary representation. And if you pick one at the first position, you have to make it tight. But in the next situation, although you pick up the one in the first position, you can still choose zero and one because the one is available here. But the important thing, you have to make it when you choose one again, you have to pass it to um, next position as a tight still. When you choose one one, in the next iteration, next recursion, it has to be tight as well. But what if you choose one zero? It means you are decreasing the number compared to the original binary representation. So it is no longer tied. You can choose whatever number, I mean, only one and zero is available, but it can be one or it can be zero. So it doesn't have to be tied when you pick up a zero at the index of one. So let's look at this again. So if it's tied, the limitation of numbers is going to be just the integer of your current position. So in this case, um, if you pick up one and then you're here and it's still tight, the limit is going to be one because that's the allowed number. But if it's zero, you make it tight by choosing one at the first index, and then you're now here, then only option you can take is zero because you cannot take one. So that's how I handle this limits variable. And if it's not tight, obviously it's one, always one. And this for loop, it's just really simple, limit plus one. So it's going to be zero or one if the limit is one. Obviously, if the limit is zero, that's going to be only zero. Digit is going to be zero. And the first condition is this. And as I told you, if the parameter is one and then digit is also one, that's going to be invalid. So you're going to skip it. Continue. And this is what I explained earlier. If the type is one, if it's already tight, and then you pick up the same number as limits, the next type is also going to be one because again, like if you choose if you have numbers like 110, and if you pick 1, which is the same as limit, it the next recursion has to be typed because you cannot pick one here. Okay, so it's already tight, and then when you're here, and then you're maximizing the numbers until the position one, the next recursion has to be tight as well. So this is how I decide like whether the next recursion is going to be tight or not. So other than that, it's really simple. I just call the DP function again, position plus one, just you moving forward, and the next tight and the digit. Digit is going to be what? The prep. So you are just passing the current digit that you chose now, and then it makes sure that you avoid this invalid consecutive numbers in the next recursion. And you just count the number of the the varied results. And this is going to be cached in a Celto memo and then return result. So it's really simple. And then let's run this code. Yeah, so it is pretty efficient. And this is very unique type of DP solution, and it can be used um, other harder questions, especially when you manipulate the number as string. So this is, I'm not going to explain this details, but this is another good example of digit TP. So it basically you're given two numeric strings, num1 and num2, and two integer max sum and mini sum, and the thing is you have to find the good numbers, good integers. And what is good integers? So it's going to be good. It's going to be good if so the x is the range of num1 and num2, and the sum of this x as a digit is in the range of from minisum to maxsum. So this is a good example. So this is 12 as a number, but if you think of this as a 1 and 2, and if you get the summation, that's going to be 1, yeah, 1 plus 2 equals 3. So this is in the range of minisum and maxsum, right? So this is another great example because you know what is going to be um, the variable that decides the type, so which is the minisum and the maxsum, and also this numbers. You cannot exceed these numbers. So this is going to be your type. So you can handle this question in the same way as I did here. Okay, so before I extend this video too much, I'm going to end this. Thank you for watching. I'll see you next time. Bye.